In this video, we're going to apply problem-solving strategies to solve problems for Unit 2C. A toll collector on a highway receives $4 for cars and $7 for buses. At the end of a 2-hour period, she collected $148. How many cars and buses passed through the toll booth during that period? So we can make a linear equation that looks something like this, where x is the number of cars and y is the number of buses, and it looks like so. And any ordered pair, for instance, this one is 34, that you plug into this equation, that comes out to be true. 30 times 4 is 120. Plus 7 times 4 is 28, and 120 plus 128 is 148 is true, would be a solution. So let's graph the line here by solving for y and putting it into a graphing calculator. I've used Desmos here, and let's just show you that, well, I did use Desmos here, but let's solve that again. So 4x plus 7y is equal to, what was that, 148. The equation of the line is there. And so we're going to rewrite that as 7y equals negative 4x plus 148. And then take the next step here to say y equals negative 4/7 x plus 148 divided by 7. The reason I've solved for y like that is so that I can come in here to my gear and make a chart, a table. Now I can come in here and plug in some of these x values that they give me, like 30, and it'll solve for the fact that it's 4. 9 should give me a 16. If it gives me any other number, it's not right. So this is right. And then 16, I want to check, is 12. That's good. 32 doesn't come out evenly, so that's not good. 4 and 19, I'm looking for next. Nope. No rounding. We're not allowed to round. 2 and 20, I think, is a solution. 2 and 20 is right there. Yes, it is. 0 and 21, I don't think so. Nope. 18 and 11. Let's try that. 18 and 11, no. But let's try 37 and 0. Yes. And let's try 23 and 8. Yes. So that was just a quick way to test all of them. Because this is a linear equation in 2 variables, we can graph it and find the relationship, and any solution to the linear equation should lie on the line. We should not get any decimal part to either of the number of cars or buses, because we can't have a fraction of a car or bus. All right. Let's move on to the next one. Suppose you are designing a rectangular garden and you have 36 meters of fencing with which to enclose the garden. Can you enclose a garden with 11 meters? It's 11 meters by 7 meters. Well, 11 times 2 is 22, and 7 times 2 is 14, and that's 36. You have 36 meters of fencing, so that's good. So yes, you can do that. You can do that, and 7 times 11 is 77 square meters. If it's 12 by 6, that's 24, and 12 is also 36. So we can do that. And 12 times 6 is 72. And by computing the area of other possible gardens that can be enclosed with 36-meter fencing, find an estimate for the dimensions of the garden that has the most area. Maximum area of a rectangle is a square, so the square root of 36 is 6. So 6 by 6 is going to give us the, would be a fourth of this. That's not area, that is perimeter. So a fourth of that is going to be 9. 9 by 9. 9 by 9 will be 81. So again, square has a perimeter of 4s equals 36. S equals 9. S squared equals 81. You won't find another rectangle that has perimeter of 36 that gives you more area than the square that's 9 by 9. Okay, it takes you 56 seconds to walk from the first floor, ground floor of a building to the third floor. You took 2 flights of steps to get there. So that's going to be 56 divided by 2 is 28 seconds per flight of steps. And then how long will it take you to walk from the first to the 6th floor, which is 5 flights of steps. So 28 times 5 is 140 seconds. They tell us that we can type an integer or a decimal. 140 is an integer. A woman is traveling with a wolf, a goose, and a mouse. She must cross a river in a boat that will only hold herself and one other animal. If left to themselves, the wolf will eat the goose and the goose will eat the mouse. How many crossings are required for all 4 creatures? That includes a woman to get across the river. So tell you how this is done. So you're going to have to leave the wolf and the mouse over on this side and take the goose over with you. And then you're going to have to return back by yourself with the goose over there on that side. So that's going to be 1 trip across the river, 2 trips across the river. And then you're going to pick up either the wolf or the mouse. It doesn't matter. Let's pick up the mouse and leave the wolf over here. Pick up the goose, drop the mouse. Goose comes back with the woman. Drop the goose, pick up the wolf, and have the wolf and mouse over here. The woman comes back by herself. 5, 6. And then take the goose over there with the woman, and you have wolf, goose, and mouse over here, and it takes 7 trips. It's kind of a classic logic puzzle that's done with different animals and things like that. So just take the 2 things that don't that are on either end that don't eat each other and leave them on one side by themselves on the starting side, while you take the one that's in the middle over, and then you have to pick up the thing that's in the middle and drop it. They won't eat each other while you're there, while you're watching, so you can make the swap. And you want to get that same situation where you leave the thing in the middle over on the original side of the river by itself until last. Consider the following complex problem, which does not have a single straightforward solution. Describe how you would approach the problem without carrying out the process. List the assumptions and information needed to carry out your solution, and assess the uncertainty in the assumptions and data. Decide whether you believe the problem can be solved and whether a particular solution might generate controversy. So suppose that a city added new bus routes and handed out free bus passes. How many people would give up driving in favor of the bus? And how much money overall would this cost or save the city? So things that you would need to know to carry out the problem would be if the bus routes are more convenient for drivers. We don't need to know the number of traffic lights. We need to know the cost of buying new bus passes and hiring new bus drivers. We need to know the amount of money saved by the city by having more people ride buses. And we need to know the cost of the free passes. We don't need to know the number of drivers in the city, and we don't need to know the types of cars driven in the city. Could any of the needed data identified above potentially have ambiguous or uncertain answers? Yes. Convenience for drivers is more, I think they mean to say subjective than objective here. But C is the correct answer here. What you decide is convenient is different than what other people might call convenient. I think they got these words backwards, subjective and objective here. That's why it's ambiguous. It's subjective. It's how you feel, if you feel it's convenient. If the data identified above is obtained, can the problem be solved? No, because the number of people who would give up driving would be an estimate, not an exact answer. And also people wouldn't necessarily stick with the choice that they made. People might just use the free bus pass for as long as it was free, and then would go right back to driving once they had to pay for their own bus pass, would be another reason. So is a particular solution likely to generate controversy? Sure. If the city does not save money and only a few people give up driving, controversy would result. Okay. So that's it for this video. We'll come back next time and keep talking about Unit 2C. See you for the next video.